Lesson 1.1 is about discrete and continuous random variables. And our memory verse for today is found in Numbers 13, verses 1 and 2. It says, "The Lord now said to Moses, 'Send men to explore the land of Canaan, the land that I am giving to Israel. Send one leader from each of the 12 ancestral tribes.'" At the end of this class, you'll be able to illustrate discrete and random variables, and you'll be able to distinguish what's the difference between these two random variables. Our NVSA boosters for today is about your favorite Bible number. In the discussion forum, you need to share with us your favorite number in the Bible and why is it your favorite, and share how is it used in the Bible story and also its supporting text. Our venture activity today is about what's the number. Like you ask two people of these 6 questions, then you try to analyze or to observe what have you noticed in the answers, and are these numbers exact or with a fraction parts. 2 big words for today. We have discrete and continuous. Discrete and continuous data or variable come from a quantitative data. Remember, if we say quantitative, it means n. The answer is a number. So it is a numerical data. So numerical data can be discrete or continuous. When is it discrete? I'll not read the whole definition. You can download the lecture notes, but here's my simplified definition for it. If you say discrete, it's a positive whole number. What do you mean by that? The answer will only be 0, 1, 2, 3, 4, 5. These are counting numbers. But if you say continuous random variable, it means that the answer or the numeric variable can take a part. What do you mean by part? It can take a fraction or a decimal after the whole number. Like it can have 1/2, it can take the value of 3/4, 0.75. These are continuous random variables. But again, if the answer will only be a counting number, like 1, 2, 3, 4, 5, no parts, it means the data is of a discrete random variable. Let me give you an example. Examples of discrete data. Number of COVID-19 patients. The answer will always be 1, 2, 3, right? You could not give an answer of 5.5 or 6.5 or 7 and 3/4. The answer is always a counting number. Or another, number of enrolled students. The answer is always a counting number. That's 10, 15, 20. Number of schools. The answer is a counting number. Number of harvested apples. The answer is always a counting number. So these are some examples for discrete random variable. But if we say height, your answer could have a fraction, right? 60.25 inches. That is a continuous random variable. Or we say mass. How heavy are you? The answer might be 23.775 kilograms or 23 and 3/4. There's a fraction part. So it's a continuous random variable. How about age? You might say that age is a discrete variable because we just say, I'm 17 years old, I'm 18 years old. But in reality, age can have a fraction part. Like you can be 17.5 years old. If you check your card, there's always 17 and 3/4 or 17 and 1/4. Next, prices. prices are always continuous. It can take the fraction part, like 12.36 or the decimal part. So again, if the answer is a counting number, the variable is a discrete random variable. But if it can take a fraction part, then it's a continuous random variable. Here's a tip. You ask yourself, can the answer be 1/2? If the answer can be 1/2, then it's continuous. But if it can't be 1/2, then it is discrete. For example, number of hospitals. Can the answer be 1/2? No. So it is discrete. Another one, allowance. Can it take a fraction part? Can it be 1/2 or 0.50? Yes. So allowance is a continuous data or a continuous random variable. That's why I disagree with the concept of mathematically, I disagree with the concept of the boat is sinking. Then group yourselves into 3 and 1/2. And then the fourth person will just sit because it means 1/2. But in reality, if you count, even if you're sitting or even if you're standing, that's still 1, 2, 3, 4. And there's no 1/2 when it comes to population. So that's